Okay, let's try another one of these sign diagrams. So I'm going to try one now a little bit harder. Let's jump down. We're still on 2F in the book. And let's try problem number 4. Why don't we do 4A? Let's just start with the first one. So let's see. You've got now a function, rational function, we call these, or a fraction, right? It's x plus 2 on top, your numerator, x minus 1 on the bottom, your denominator. And hopefully you remember, or it'll come to you right away when I tell you, when you have a rational function, there's always a very interesting point you have to take into account. When there's an x in the bottom, we always have to make sure that the denominator can't ever become 0, because it's against the rules of the universe to divide by 0. Can't do it. So that is a restricted domain. If you remember that, x can't be, in this case, can't be 1, right? And to find out what that is, you always have to set it equal to 0. You set the bottom equal to 0 so that you can know what it can't be. In other words, I'd be like x minus 1 equals 0. Add 1 to both sides, x equals 1. So I can't let that happen. So when you're graphing it, remember what we're trying to do is draw sign diagrams. You have to remember a funny thing is happening at 1. It's like a hole, like there's a spot in our graph. When x is 1, there is no y value. I don't care about the top, but when x is 1, there's no y value. So typically when you graph that, you draw that dashed line, that hyperbola, or I'm sorry, that asymptote. Hyperbola is the name of the funky graph, right? The asymptote is the line, we call that line that the function can never actually touch anywhere on that line, because there is no value for y or for the function, because x can't be 1. So what we're going to do when we make our sign diagram, we're going to draw, we're going to find that point right away. So I'm going to find all my restricted points, if you will. I'm going to put 0 on there just to keep track of where I am. And then I want to go to 1. And I'm going to draw that dashed line. The way they did it in the book, their teachers just draw it up, just a little bit. They drew it up a little bit. So that shows us that at that point, that's like a restricted area. There's no plus or minus. There's just nothing. It's not defined. So now we have to figure out, well, what's going on to the right or the left. And even before that, let's take a step back. So if you're doing notes, step 1 is checking with the denominator, find the restrictions to the domain. Step 2, come to the numerator, beep beep, and find the zeros. And so this one's easy. It's just x plus 2. So what's the zeros of that? Just set it equal to 0. Of course, it's x equals negative 2. So when x is negative 2, I have a 0. So let's go over here and mark that. I'll put it back to black. And just stop for a minute. It's kind of interesting to realize that when x is negative 2, we found a 0. But do I have to worry about the denominators? Don't I have to also put the negative 2 down here and see what happens? And if you think about it for a minute, you don't. It doesn't matter. Because once the numerator becomes 0, who cares if the denominator could be, 25. But 0 divided by 25 is still going to be 0. So that's why you can just focus on the numerator to get your zeros, to get your roots. All right, so I'm going to erase that. Got the roots. There's only one root in this function. So that's that right there. So now we got to find out what's going on to the left and to the right. So to the left of 2, let's pick a number like, an easy number like, not 2, but negative 2, sorry. Let's pick a number like negative 4. So when I'm negative 4, I'll substitute it in. And I'm not going to even worry about calculating too much. A negative 4 and a positive 2, I know the top is going to be negative, and the bottom have a negative minus, or a negative combined with a negative. That's the way I would like to look at it. A negative and a negative. That's going to be negative. So I'm ultimately going to have a negative divided by a negative, which of course is going to be a positive. So I'm not even get caught up in trying to figure out the value. And then I'm going to go to the right of negative 2, and it better be negative, right? So let's pick a point like 0. Why not? So put in 0 plus 2 and 0 minus 1. 0 plus 2, that's going to be positive. 0 minus 1, that's going to be negative. Positive divided by negative, negative. And do we need to check more? I don't think we do. I think it'll be negative everywhere, even on the other side of the asymptote. But if you want to, just to make sure, we could put another number in, like 10. 10 plus 2. Ooh. Wait a minute. What happened with that? 0. Okay, it looks like we do have to be careful about 1. Okay. So we better go to the right of 1. You see. So 1 is a special point. It's not, it's like a 0. Okay, good, that makes sense. Because on asymptotes, a lot of times the graphs are going to be like negative on one side of the asymptote. It's going to be like, I think this one's going to be like coming down like that, negative on one side. And the other side of the asymptote, it's positive. And it comes down. Something like that, maybe. So, okay, so we do need to be a little more. We can't be, I'm doing too quick. So I come to 1 now, and then I say, what's to the right? Just to the right of 1, how about the number 2? So put in 2 plus 2 on top, 2 minus 1. And sure enough, it's going to be positive. Good thing we were a little bit careful. So my graph is going to be, it's going to go from positive, and then at negative 2, it's going to switch to negative. See how I graphed it right there? Just sketched it. It's positive, then it's switched to negative. And the reason I chose that shape is over time, as you start to graph these, you start to get pretty familiar with how these shapes tend to look. And you know that, we can talk later in another video, how it's diving all the way down to negative infinity. So your sign chart just tells you it's negative. But when you think a little bit more and you start to pick a few points, you'll realize it's not just negative, but it's like really, really negative, like negative 10,000. And then on the right, to the right of 1, it's like positive 10,000, positive 20,000. Of course, it's actually right, the very little point right there is positive infinity. So the new graph, the other side of the graph will come shooting down. And it tends to like taper off. So there you go. That's our sign diagram for that one. That was a longer video.